Okay, it's just 10:30 now, so I think I will go ahead because we don't want to keep anyone over today. So hi everybody, welcome to the next episode in our Open Networking webinar series, Unboxing Open Networking, the Hardware Within. My name is Ciara McCarthy. I'm the Global Marketing Director for EPS Global. Just to give you a bit of background on EPS, we are the open networking distributor of choice globally for a whole host of industries. We sit at the center of the open networking ecosystem, bringing together the hardware and the open NOS software to create turnkey solutions for our customers. We offer technical advice, configuration of software and hardware bundles, that's switches, optics, cables, and more. We've been around for 20 years and we've 28 global locations, so we're never far away. So just a bit of housekeeping for today. If you have any questions, don't be afraid to ask them. You can type them into the chat window and Barry will answer them at the end. If there's anything that we don't get to, we will follow up with personal emails to you after the webinar to answer anything. Okay, so the agenda for today. We're going to start with who is Edgecore Networks, the evolution of the hardware and use cases, contributions to the OCP, the Open Compute Project, the Edgecore Lab, open NOSes and cross-pollination, and finally, the direction and momentum of open hardware and the OCP. So just to give you a quick intro to our speakers today, we are delighted to have Łukasz Lukowski from Edgecore Networks with us as a guest speaker. Łukasz leads Edgecore Networks channel sales business in EMEA, and he's responsible for establishing and developing distribution and reseller relationships across the region. He has expertise in the network infrastructure, data center, security, and associated technology markets. He is one of the first open networking evangelists in Europe and has been working closely with the OCP, TIP, the ONF, he is an A-Team ambassador there, Terragraph and Express Wi-Fi program to help make change happen in the EMEA region. Next up, we have Barry McGinley. Barry McGinley works for EPS. He is our systems engineer for EMEA, and he's our resident techie with a broad knowledge of open networking. And he supports all of our customer engagements. Barry enjoys a pint of Guinness, and he's an avid Celtic supporter. I'll let him speak for himself later, but he writes an excellent monthly blog, which is on our website at epsglobal.com. Finally, our second guest speaker is Steve Helvey, who is the VP of Channel Development for the OCP. Steve helps to educate organizations on the benefits of open hardware designs and the value of community-driven engineering for the data center. He works closely with solution providers and manufacturers to help organizations adopt open compute across all regions and segments of the market. Steve has held various leadership and channel development roles for companies like Microsoft, AsiaPac, and Rackspace in the UK. So I will now pass you over to Łukasz, who will speak next from Edgecore. Thanks.
Yes, much appreciated for that also introduction, and I'm really grateful to be here with all of you. So skipping our agenda, I would like to share with you a little bit more details about Edgecore Networks. So once again, my name is Łukasz Lukowski. I'm working on Edgecore Networks. I'm focusing primarily on the sales and channels and covering the EMEA region. But before I will give you a rough idea about the Edgecore Networks, always it is right to start from our mother company, from the Acton technology. So Acton is one of the ODM, Taiwanese ODM, original design manufacturer, definitely leading the networking ODM business for today more than 30 years. If you will go over some briefly figures, you can see that the last year as a whole group, we've been able to close on $1.8 billion US. which is also interesting to mention that when you see some others ODMs, the primary difference, and I'm really saying that with a great honor and pleasure, is that we are focusing on the networking. So those 30 years of the experience, it is a real experience coming from the networking, both wide and wireless, where some other similar companies, which you can see on the market, they are coming from the server or the storage world. So it's a little bit different story. We have around 5,000 plus employees, around 1,000 engineers, and we are really able to provide high volume manufacturing. Our factories are located in China and also in Taiwan. Frankly speaking, we have even a pretty brand new one in Taiwan. Acton is providing the hardware for most of the tier one brands, which you know from the market. I don't want it to bring any names, but those all manufacturers like, as an example, Cisco, Dell, HP, and others, they are using such as company like Acton Technology to design and manufacture their hardware. Then going back to the Edgecore, we are like a branded business inside the Acton Technology. Company being started in 2004. We've been focusing on a couple of different markets, starting historical from so-called traditional business, where we had our traditional switches, NAPs with our own software. But today, primarily, we are focusing on open networking and open hardware, bare metal switches, which I would like to share a little bit more today with you. We are a leading contributor of open designs. We've been one of the first members at Open Compute Project. We are also working very active at TIP and also supporting ONF. Speaking about the volume, just as an Edgecore, last year we've been shipping more than 10 million Ethernet ports, and I can tell you that most of them being related with 100G speed last year. I really like that slide because it is simple, but saying and showing a lot of direction. So this is showing how the whole evolution of open networking started. More than 6 years ago, it will be, we all been starting in the data center disaggregation. So the first 10G and the 40G switches. And as you can see today, even that the open networking been born in the data centers, it's been evaluating and migrating to also different area, different markets like the telcos, enterprise campus. So starting from the data center, primarily what is changing over those whole years, speed, the speed, the throughput, definitely this is something which is growing. As I mentioned it, on the beginning, that was a disaggregation of the first simple even spine, 10G, 40G. Then we had 100G switches. Today, you will find 32 100G, 64 times 100G, 28, 256, and even 512 times 100G. So definitely that is growing. Of course, for more than 1 year, we are already with the 400G. And that is also evaluating. Then going to the telco market, like a tier one, especially operators, those gentlemen, they are also able to use some 10G, 40G, 100G switches, but we very soon realized that there are some unique requirements coming from that market, which are also related not only with software, but also with our hardware, like a higher buffer or external TCAP, or we have to deal with some environment challenges where we are going to the street cabinets and so on. then, of course, to complete the portfolio and be able to offer a really solution where you are able to use in your data center, but also in your campus, enterprises, or even your warehouses, from that market, there were also coming some basic requirements like a PoE, like some VXLAN support. So that is also a market of our focus, and I will show you some couple of slides right away. So data center, this is a typical leaf and spine topology. Today, your leaves could be 10G or 40G or even 100G. Of course, when you are using a breakout cables, I believe that I shouldn't repeat that, but I can again mention about that. We can split the interface 100G to 4 times 25G, 4 times 10G, or change the speed from 100G to the 40G. So the fully 100G you can also see as a leaf switches. And then we are going to the up to the spine, which primarily today are 100G or slowly 400G. In the past, you can also see here 40G switches. So we will not go over our 100% portfolio, but I would like to share with you some of our interesting cooperation with some hyperscalers like a Facebook, where we can share officially. So we've been working with Facebook for a good couple of years, and we are manufacturing a few models for Facebook. We've been starting from a wedge called 16X. That was a tried and true, a little bit older today design with 16 times 40G. Then we've been switching to fully 100G, 32 100G, call it wedge 100S, and something new, which is already, by the way, used by a Facebook in the data center. That latest design is called Mini Pack. It's really nice. It's modular. So we have there a single ASIC. It is the Tomahawk 3. We have really powerful CPU, Intel Xeon, and we have 8 slots for our line cards. Today, we do have 2 line cards, 60 times 100G or 4 times 400G. So that box really is able to scale your whole traffic from the east to the west, because you are not limited to 32 or 64 times 100G like in the past. You can even go from one single ASIC and CPU to 128. But also, if needed, that box could be potentially your leaf switch. Of course, you will have to manage your cables a little bit differently, but this is also an option. You can just put a 400G line card or 2 and go up to fully populated 32 100G mini pack. Going to the telco market, they are also taking some leverage from a leaf and spine topology. So I have on mine a close, and there is a couple of different version or variation of a topology or topology called code, central office redesigned as a data center. So if you will take a look, this is like a typical leaf and spine, but when in the data center market, we are connecting here your server and storage primarily. Here in those leaves, we can aggregate your open OLTs or go with maybe your edge routers and so on, so on. So there is a couple of, let's say, different variation of that core, like a residential core, e-core, enterprise core, mobile core, and analytic. And we as an Edgecore, we are focusing on a couple of areas of the typical telco network. So if we will take a look on the architecture, we have an access, aggregation, and telcos, they also do have their own data center. So speaking about the access, we have so-called universal CPEs, which can be also used for some enterprise customers. we are going over passive optical networks and open OLTs, or we are also going to 4G, 5G network mobile backhaul. I will show you also some slides. Then for the aggregation, this is where some other requirements are coming, like a large TCAM or higher, like typical buffer. And going even to really big disaggregated routers. This is also what you can find in the open networking. So not like those few years ago, open 10G, 40G, 100G switches, but really designed specialized hardware for a lot of different purposes. So just maybe a few examples. Speaking about the disaggregated side gateways, we have today 3 designs, and it's looking like a really compact box. We have, for example, 60 times 10G, some uplinks like a 25G or going to the 100G, 2 times 100G. But the challenge with devices like here is that it's not any longer a nice and cozy data center environment. We are going to the street cabinet, so we have to deal with the temperature. We have to deal with additional, as this is for a mobile application, we have to deal with the time synchronization and so on, so on, so on. So that series is also growing. We've been starting from the first design. Today we have 3, and we are also thinking on a couple of different ones. But if you wanted to imagine when you will find that box in the telco network, that will be more or less almost like a last switch which will aggregate the traffic from the base station. So again, requirements related with the temperature, -40 plus 65, time synchronization, and a chipset which you will not find in the data center portfolio, a chipset more dedicated for routing. Like this is a combination of the Qumran chipset, Qumran AX or UX, depends on the throughput. Access is a really huge part of the telco network. I base in Poland. In Poland, we have a lot of PON network, passive optical network, primarily GPON, but also there are some pilots where we are doing some tests with the 10G PON. So we as an Edgecore, we've been the first with the open disaggregated OLT. We've been starting from the 60 times 10G and 4 times 100G. And this is a really cool device. You have a combination of 2 different families of the chipset. So from one side, you have a Qumran AX, which will help you with a lot of routing stuff. From the other side, you have to deal with the PON termination. So we are using the MAPO. But also we are working on a next generation of such as devices where really that will be a nice and cool flexibility where we will be able to use those interfaces as a 10G or PON or GPON and so on. And that will give a lot of flexibility where we will be able just to change it from the software perspective. Going to, let's say, more like a core routers or aggregation routers, there is a couple of different designs where we will be able to use as really powerful routers. So it could be like simple standalone with 80 times 100G. We have some models with 40 times 100G, 30 times 400G, where you will be able to stack them together, or you will be able to use a combination, again, closed topology, leaf and spine, and really build a distributor virtual chassis. But the difference with those boxes and, I don't know, Minipack as an example, is that those are routers. Again, large TCAM, buffer, definitely something that you will not find, or what is maybe not primarily used for a simple spine switch, whatever 100G or 400G, which primary task is switch forwarding or fast switching forwarding. And enterprise. So Again, it doesn't mean that someone cannot use 10G fiber switches or 40G or 100G switches in the enterprise. Definitely you can. But the primary requirements coming from those markets are related with the copper interfaces. So today we have switches, PoE switches, copper switches, a model or a series like 4610, 4 models, PoE, non-PoE, with Ultra P support and so on. What is new and coming soon, it is a next generation of such as access switches, where we are adding 2.5 gig and multi-gig interfaces. When we are upgrading the uplink from 10G to 25G or 100G, where the PoE budget is even higher. We are not only supporting PoE plus, Ultra PoE up to 60, but even a PoE, so-called mega PoE up to 90 watts, which could be useless. It will be very useful with some digital signage project where you can power, for example, some info kiosk and so on. Additional in that market, you will also find so-called universal CPE. What it is, this is like a small device with primary Intel inside, a few ports, but based on specialized software, you can force those boxes to working as your router or VPN or firewall. Because finally, if you will take a look on that traditional world, what is a router? What is a firewall? It's nothing else like a hardware with the right performance as a specialized software. So we are also opening that part of the technology and contributing that everything what we are doing back to the OCP. As a cherry on that cake, what we are also doing with the enterprise and campus are our activities related with the wireless. If someone will be interested, I really encourage you to take a look more about a project driven by Facebook called Express Wi-Fi. We are really active there, so it's about 60 gigahertz point-to-point, point-to-multipoint connectivities, and also some agents which are able to run on our hardware and a hardware of the other vendors. But primarily, the telcos, some ISPs could take the leverage from that solution and even mix the vendors have one provisioning system and so on. So really, really nice thing. Speaking about the contribution, one of the idea of open networking is that finally, there are no any secrets. Everything what we are doing, we are contributing back to OCP. So it means that when we've been the first with the 10G switches, 100G switches, 400 switches, and so on, we are really providing a details information how the hardware we are building, what is inside, what we are using, what vendor for the, I don't know, memories, hard drives, everything like that you can find in our specification. This is to help, let's say, the others to develop similar hardware and make it even, more open and available. We are not only focusing on, as I was mentioning, that hardware for our data centers. It was born there, but definitely it was migrating. And today, our open designs are primarily covering the almost total, all the markets. We are starting from 1G switches, 10G switches, 25G with 100G switches, 40G switches, 100G switches with 32 interfaces, 100G switches with 64, 100 switches with 128, and even up to 512 times 100G. The 400G 32 right now, but we are also working on even bigger 400G and OLTs and SASI gateways and the routers. So that is a really nice thing about the OCP, that you can go there, and even if you are not an official member, you can just take a look, really, how we are doing that, how the others are doing, what is inside. So if someone would like to try and is thinking how to start, we have a hardware, definitely. I will park the part related with the software, but we will let you know a little bit more about the different software options. But even here in Europe, in Poland, in our office, we have our lab. So if someone would like to, put their hands remotely, that is not a problem. We can set up most of the topology, put different software on top, PK8, Cumulus, whatever what you need, whatever what you want to try. Maybe a Sonic, which is really today very interesting topic. But also additional, we have so-called like a mobile lab. There are those boxes on that slide. You can see our SIBA demo. So this is our disaggregated mobile passive optical network lab. But we can also set up a leaf and spine topology. I don't know, depends what you would like to try. Maybe so mix of the latest Trident 3 switches with, I don't know, Tomahawk 1 or 2 and specific software. More than happy to help to set up such as lab and send us along to some of you to play around. So that will be everything from my part. Really appreciate it.
And thanks, Kira, for that lovely introduction. Glasgow Celtic even got a mention, which is great. And thanks to all the attendees. Thanks for giving us a piece of your day, which is brilliant. So my name is Barry. I'm a network engineer with EPS, working on open networking for the last 2 years. So today I'm going to talk to you about software, about commercial and open source software. This is actually, just to let you know, this is actually the second webinar in this series. In the first webinar, it was called Bare Metal Basics. We had a look at how open networking came about, some of the players in that. So the OCP, the ONF, the Telecom Infra project that are looking to do end-to-end solutions. We looked at some of the terminology within open networking, like bare metal, white box, bright box. We also looked at switching ASICs, and we touched on software. So again, today, I'm only going to touch on the software because our upcoming webinars are actually nearly all software based. So the next webinar we have next month is going to look at a Cumulus deployment, a Cumulus data center deployment from start to finish. We're going to look at IPI, so IPM Fusion with an end-to-end service provider solution. So Lukash mentioned a few of the products there: cell site gateways into aggregation routers, into Cassini transponders, OLTs, all the stuff that service providers need. We're then going to look at Pluribus. So Pluribus can do data center interconnect, fabrics over multiple data centers, which is quite cool. We're going to do one with them. And then we're going to do one with Abstra. So we're going to look at AOS, which is an automation and management platform that actually sits above the operating system. So it would sit above Cumulus or Sonic, or something like that. So I just want to mention EPS as well and what we actually do. Like I know Kira did touch on it, but just to give you an idea of how it works. So I'm saying we're distributors, value-added distributors globally for a lot of companies you'd know, so Finisar, Amphenol, so on and so forth. But then in 2016, we started partnering with Edgecore. And I think we kind of quickly realized that it wasn't going to be the same way as distributing a normal product, because the hardware is only one part of this. So we had to look at the software side of this as well. And not only talk to the software vendors, talk to all the software vendors, and explain to you now why. So when a company comes to us and says they're interested, now that can come through the hardware side or the software side. But they'll tell us about their use case and they'll tell us what they're trying to do. And pretty quickly, we'll kind of know, say it's 10 gig and 25 gig as your spine, we'll kind of know which chipset they're looking for. So whether it's the Tomahawk, whether it's Trident 3, or whether they need Qumran. And then we'll get an idea from what they're trying to do on which software we'll actually use. So this is important, that we're what we call vendor agnostic when it comes to software. So we know them all, we work with them all, but we're not going to pigeonhole one specific software into a network when it doesn't fit the use case properly. So what happens then is, usually with the companies, we'll either move to giving them hardware. So I love to give companies hardware. We'll give them maybe 3 boxes so they can simulate spine and leaf, and then let their engineers beat up those boxes. Well, not beat them up too hard now, but beat them up in the lab. So say we give 2 operating systems. We give Cumulus Linux, and we'll get trial licenses for our customers, and they'll work away on them for 2-3 weeks, and then we can get trial licenses for, say, NetVisor 1 from Pluribus and stick them on. And then after this point, we can actually bring in the system engineers from the software guys and start to look at proper implementation, proper configurations. And then our role doesn't stop there either. Once we're ready to implement, what we like to do for our customers as well is put the software and the licenses on the switches and send them off to the customer. So basically they're ready to slide into a rack and configure. And then obviously we can bundle in transceivers, cables, and all sorts. So we're trying to make open networking a little bit easier for our customers. So I'll get on to the software. So I've split the software into commercial and open source, and then the commercial is split into data center, communication service provider, enterprise, and then management and automation. But again, you'll see that you'll see why open networking software covers so many use cases, because again, we're in data center here now, and this is split again. So we have what we call individually managed, and we have centrally managed. So individually managed would be Cumulus and, say, IPI. So what you're still managing the individual boxes. You can use DevOps tools like Ansible, Chef, and Puppet to push that automation to the boxes. We are still pushing the configuration to an individual box. And then you have centrally managed. So, and again, this is split in 2 different ways. So Big Switch and Pluribus have centrally managed options, but they do it 2 different ways. So Big Switch uses a controller. So they separate the control and data plane, and the control plane sits above and basically gives all the forwarding information to the switches. So they're far from dumb switches, but they're allowed to just concentrate then on forwarding. Pluribus does it a completely different way. You can manage with Pluribus Adaptive Cloud Fabric, you can manage multiple data centers from any switch in any of those data centers. And we'll cover that again when we speak to Pluribus. Communication service providers. So this area is starting to get really big. The work that ONF and the Telecom Infra project have been doing. So at the top there, and there's new companies coming here every few weeks, it seems, because an awful lot of them have been doing large proof of concepts with telcos that have taken up possibly years of their time, and then they kind of come out into the market. So I think RT Brick at the minute are in a big proof of concept with a large German telco, and their idea as well is an end-to-end solution, so that your switches are going to use RT Brick NOS, but the OLT is the virtual broadband network gateway is your edge and aggregation switches, so it's a full end-to-end solution. We've IP Infusion there as well. I said we're going to speak to them in the coming weeks and months. They have OLT software, Cassini that Lukash touched on, cell site gateways. So again, they're trying to produce an end-to-end solution for service providers. And then saying there's an awful lot more in this area. We Volta networks, they go on the cell site gateway and virtual routers and things like that. So enterprise, again, that's just a snapshot of the options available. So we've Picos is their option, and they're one of the older vendors, one of the oldest vendors in open networking. Pluribus network. So Pluribus, you can have your fabric, but they have NetVisor 1 as the operating system, which can work well in enterprise. And then we've Cumulus Linux for campus, I suppose you can call it. So that's what they're calling it, Cumulus Campus Networks. And the reason this came about was their data center customers started asking them, would it be possible to do our campus network in open networking as well? And at the time, it wasn't possible because the protocols required for Cumulus Linux for the data center, we needed more than basically for the campus. So say spanning tree, port security, multi-gigabit, they had to go off, add all these. But now that they've done it, their customers basically can now manage their data center and their campus networks with the same automation and management tools. So that's something pretty good. Management and automation, we have a couple here. So Netris, formerly called xCloud, and then Apstra. So Apstra have a product called AOS. And basically what you can do is you can design your network in software, right down to basically all configurations. You can commit that, see if it'll actually work. It'll tell you where there's errors, fix the errors, and then you can actually implement that exact design and know that it's going to work. They also have this pretty cool function called Intent Time Voyager, where you can save 5 good known configurations. If your network goes down, 3 clicks of a button, and your network is back up and running to a good known configuration, which is kind of black magic. So open source software. So most of the open source software is actually run by kind of foundations or projects. They have to be big enough, I suppose, and have a big enough community to have buy-in. So we have ONL on the top right, which is Open Networking Linux, and that's a foundation level operating system. So basically, if you wanted to build your own operating system, you'd use ONL as the base, and then put your own protocols on top. Big Switch is based on ONL. We have Open Switch from the Linux Foundation. So this is to do with composable networks, where we try and pool resources. So you pool your network, your compute and storage. We've Danos with the Linux Foundation. So this is AT&T's operating system. They recently gifted it to the Linux Foundation. I think they were supposed to, or they'd planned on doing it in 2008, but it was November 2019 when it actually happened. But as I kind of watched this space with Danos, we have Stratum and Onus from the ONF. So the ONF, I covered some of this in the first webinar. So the ONF run projects and platforms like SIBA, which is for software-enabled broadband access for residential and enterprise broadband. Comac, Trellis, which is spine and leaf within the central office. But what they want to have is an operating system that runs through all their projects and platforms, and a controller that sits above all of these. So this is what they have. Stratum is the network operating system, and Onus is the controller that sits above that layer. And finally, we have Sonic from Microsoft. So I know Lukasz again briefly touched on Sonic. So this is software for open networking in the cloud, and it's from Microsoft. So I think since 2016, this has been working in Microsoft's network, and they gifted it to the OCP maybe 2008. I think Steve will know anyway. But Sonic is very interesting because it's container based. So when we think about Microsoft worked on this and put in the protocols that they needed. So maybe they use BGP and they don't use ISIS or OSPF. So they didn't build those containers. But then now Alibaba, Tencent, LinkedIn are all using Sonic now as well. So each time there's a deployment, there's new containers being built. So the repository of containers is building all the time. And it'll get to the point where just about every use case is catered for. So Sonic is definitely one to watch this space with. And I think we're pretty tight for time. So I have a few other slides, but it's kind of regurgitating what Lukasz said. So I'll hand you over to Steve Helvey from the OCP now. So thank you very much, guys.
Hi, Barry. Thanks. I hope everyone can hear me. Barry, if you'd be so kind enough to go ahead and forward the slide. A couple. I'm having some slide issues on my side.
No problem. 1 sec.
Thanks. So really, I just want to cover on a couple things. Barry, you can move it forward there on how does this translate into the market? So there's really, as Lucas mentioned, all the different types of products that we have. Barry talking about how the network operating systems are maturing. the way that this is translating into the market is pretty substantial. We're seeing a great deal of growth across compute and storage, but primarily networking. And it seems as though open networking is the most palatable or the easiest way for people to start to try open hardware. As you can see in the bottom right here, we have the entire open bare metal switch market. As of just a couple quarters ago, the OCP switches are accounting for more than 50% of those bare metal switches. And we see that continuing across different markets, whether it be a need for CapEx reduction or the type of software enabling features that you get. And so what really makes the difference around this is having a community. Barry, if you'll move it forward to the next one. So there's a lot of people that are involved in open compute, but the reason that I wanted to pull up these three individuals is that it takes an enormous amount of time and effort to participate in open compute. There are meetings, there are workshops, there's managing inbound contributions. So it's not just as if people are joining open compute and then having, say, a couple meetings or using the logo to brand themselves. They're actually dedicating an enormous number of resources across the community. Jeff Catlin here, who's on the left-hand side, he actually chairs one of our incubation technical steering committees. And George, who is the CEO and president of Acton and Edgecore, he is the regional lead in Taiwan. And of course, Lucas here has stepped up recently to become the volunteer for the EMEA location as well. So again, a lot of resources coming from Edgecore to not only just help within the community, but also to set the direction. And they'll work with end customers and also work with competitors to drive this initiative forward. And this has all led to really a new type of procurement model. You have the old traditional model of technology coming into OEMs and then the OEMs moving it out to the end customers. But with the open model, Barry, if you'll forward 2 slides ahead, the next one, great. This is how it works now, is we have Edgecore creating the technology and then people like EPS providing an enormous number of services around open technology. As Barry alluded to, all the different types of software that you can have options for. And Edgecore as well makes a lot of different open products, and we have other members in the community making other open hardware designs. So it takes somebody like EPS that has the skill set and the relationships with all of these different open vendors to create the open ecosystem and drive that value toward the users. So with that, I'll turn it back to Kira, and thank you, Barry, for helping me here on the slides and the movement.
No problem. Thanks, Steve. Okay, guys, I think I'll finish off. So thanks for your time. I don't think there was many questions there, or was there any? John, a question, where are people? John, I'll come back to you on that. I thought John would have a question, he always has. So just a quick reminder on a couple of upcoming events. So the OCP, obviously OCP Summit was cancelled. So their OCP Virtual Summit is from the May the 12th to May the 15th, which is going to be really interesting. And then some of our upcoming webinars. So we've Cumulus, public to private cloud deployment. So from start to finish, so that should be interesting. IP Infusion, and we're going to look at a end-to-end service provider solution, and then data center interconnect with Pluribus. So I want to thank everybody for their time today, and hope you all have a good day.
Thanks, Barry. Thanks, Steve, and thanks, Lukasz. It's been a pleasure, and thank you, everybody, for joining. We will be sending on the recording of the webinar in the next couple of days to you all.
Thanks, Kira.
Thank you.
Thank you, guys.
Thanks. Bye.
Bye.